vulnerability takes place at, and that would be like the link rel equals style sheet. And so it's just like that's the area where there's a violation occurring in the code. And we went over and talked to Marcin, and kind of like, we already knew that there was probably an XSS in this, but we wanted to see what different types and how far the rabbit hole really went in some way. And so we did a basic XSS which popped up, both alert window and document.cookie with the default privacy Google cookies like UTMZ and all the rest of those. And yeah, sorry we can't show it, but they haven't really, I don't know if they fixed it yet. As far as I know, we just submitted to their bug tracking system, so anybody could probably use this for abuse. The activation is the actual payload. So in some cases in code, you would see the activation. In this one, you can't. But you can see like the trigger. So the trigger would be at the bottom, the TR first child TD. And so that's the part that is really interesting. That's the part that we affected in order to make the code change, right? There's other places to find information besides MITRE, like OWASP. We already talked about that. WASC, which is the Web Application Security Consortium. I think it's webappsec.org. NIST has a lot of different projects. They have the SAMA project. They've done all sorts of stuff like over the years in security. Department of Homeland Security has Build Security In, and they work with Cigital on that type of work. And then you can just look at the source code and tools. So what is PathX? Like, basically, we're moving away from ad hoc methods. I know that like you may be familiar with the differences between programmers and security professionals. Well, security professionals and coders have a lot more in common than you think. We're all missing the same types of things. We're all missing like a specialized language, like a way of describing what it is that we do. A clear entry path, like lawyers and doctors and everybody, they have lots of different ways of like, getting into their fields, and it's kind of like a clear way, like, you go to college and, then you go to law school and then you like partner with a firm and then, you start. In security, there's no like real direct path. I mean, like, you can't say go buy a book or a certain set of books or go to college and become a security professional, become a security vulnerability researcher. There's no clear peer review either. We have like a few journals like Uninformed Journal, Codebreakers Journal, a few things like that, but it's not like really clearly defined like it is in medical or law research. And then standards, practices, and procedures. We haven't really done a lot of work with that yet either. In medicine, you say a medical practice or a medical procedure, and people know what you're talking about. If you say a procedure for security testing, there really is none. It's all just ad hoc right now. And there's the notion of cowboy coders, like, people who just, like, they're one-upping each other. Everybody's like, kind of just like wants to be the next big thing and surpass somebody else instead of share and help research. So that's a lot of the problems that we have. Ms. Marcin?
So who we are? My name is Marcin Wielgoszewski, and this is Andre Gironda. We are tsisecurity.com, and things that interest us are trusted systems, and we're fanatics about TCSec and NSA Orange Book and Red Book, and we try to apply those concepts that were developed in the late 70s and early 80s to security problems that we have today. So getting more to the testing part of this presentation, we have 3 different layers in our web applications, and we need to understand all 3. First layer that we base everything else on is our content, our HTML. We have content that's delivered from CMS systems, output to HTML, RSS, etc. It's the base for everything else we have. And it makes sure that every user can view the content, because that's really what everyone wants to get at. That's why they're visiting your site, is for the content and the information itself. On top of that, we have formatting and presentation. This is through like CSS, and it formats the page and changes the look so it's visually appealing. And what CSS has done is introduce scripting capabilities like we showed earlier with Moz binding And similar is expression in IE. And that brings us to the behavior layer, which controls user interaction and how you're interacting with the web application. And that behavior layer is mostly the reason why web apps are choice of application today, because the ubiquity of the browser and availability on every desktop that you can use. You can access any web app. And so what is XPath? When you load a web page, it's loaded into a document object model. All your P tags, A tags, forms, etc., they get loaded as nodes in the document. And XPath is a way of locating these elements and accessing them. There's 3 ways you can do it. You could use DOM selectors, CSS selectors, and also XPath. And there's just some comparison between a CSS selector and XPath. Slight variation, not too much. We get the common, some people commonly mistake XPath for RegEx. XPath is a query language for parsers, and to understand XPath, you got to know a little bit about parsers. But to understand parsers, I would go about thinking XPath like it's a file system. You can navigate the DOM through XPaths using relative and absolute locations, relative and absolute paths. And there's a couple libraries you can use for parsing.
Yeah, so like there's different libraries for different languages. libxml2 was one of the first XML parsers available that was really well done. And it's used primarily in C, but also like Perl and Python and some other languages use it. Ruby has RegXML. And these support different types of parsers, but it's all XML. And then a good one for Java would be XOM. If anybody has any other languages that they're interested in, I can give suggestions.
So this was just some, we're using XML-lint to browse document object model, or browse a web page using XPaths. The top is just like the help menu. But at the bottom, we loaded google.com with XML-lint, and we could CD, like change directory, to a certain location in the DOM, and we could view it. We could print our current directory, and we could cat it. So basically, the same file system utilities that you use to navigate your directory trees, you could use with XML-lint. So that's just to get started with XPaths, just to learn a little bit more. XML-lint. XML-LINT. So this brings us to content parsing. We've all used grep on files, right? Have you ever tried to use grep against HTML or XML, or even viewed XML inside a browser without a style sheet for it? It's not intuitive. It's hard to understand visually, and grep, you're only getting one line at a time. So what we need to do is parse it so we get the bigger picture. And there's several ways of doing that. There's document-based parsers and event-based parsers.
Why isn't HTML grepable?
Well, because you have an opening tag and a closing tag, and some of it's on different lines. It expands longer. So when you grep for something, it comes on just one line.
There's ways of doing it, but it's a hack,
So document-based parsers, they load the entire DOM. You're working with the entire document at a time, and you could do random queries against it. With the event-based parser, you're loading elements. You're getting elements as you need them. It doesn't load the entire document. You could make a comparison with document-based parsers and event-based parsers with cat and tail with -f. So when you cat a file, you print the entire contents to standard out, and you could work with it that way. With event-based parser, to like tail -f, you